Okay, Unit 10, Semester Review Packet. Once again, simple reminder that you should be trying these problems before watching this, and you should not be copying directly. You should be trying to learn this material as you go here, all right, if you don't know it already. So we have Unit 10 dealt with exponential functions, and we have a few quick little easy problems here. All right, starting off here, just making sure we understand the difference between growth and decay. All right, we read graphs from left to right, and as I read from left to right, all right, you could clearly see that we're growing. All right, so that would be exponential growth. Over here, from left to right, you see that we are going down in value. That would be decay. Moving on, example 2. We are asked to identify the growth decay factor and rate and the initial value. Okay, so again, a general form of an exponential equation looks like this, where A is the initial value and B is the growth or decay factor. Okay, so when I look at this equation, y equals 1.23 to the x, all right, if I put that in parentheses, I could see that my factor is 1.23. My initial value is the number in front, which is that invisible 1, so my initial value is 1. It's the rate that throws most people off. Okay, if I want to find the rate, again, what I need to do is look at this little formula that says the factor is equal to, in this case, we're talking about growth. I know it's growth, by the way, and I should have circled that. All right, I know it's growth because this number right here is greater than 1. That lets me know it's growth. So my growth model looks like this. 1 plus r equals f. So I'm going to put my factor, my growth factor in place, and then solve for the rate. So I end up at 0.23. I go 2 to the right. That's a 23% growth per whatever unit of time we have. All right. Number, it says 4. I guess it should be 3. I think I counted the two graphs as separate before. All right. Once again, we look inside. We see a number that is what we would consider between 0 and 1. That makes this decay. My decay factor is 0.60. My initial value is the number out in front, so 0.75. And my decay rate, well, I need to go ahead and do that calculation. Now again, 1 plus r is growth. That means 1 minus r is decay. Alright, so we're doing decay here, so I'm going to do 1 minus r, and we got to equal the factor of 0.60. I subtract, I end up with negative 0.40, but again, that r is negative, so I'm going to divide by 1, negative 1, and change it so that my rate is 40%. Remember, we got to go 2 to the right there. Okay, so you're subtracting 1, ignoring the negative sign, alright, and then move 2 to the right. Alright, example 5, which is actually number 4. Alright, we have this Gila monster who's 16 centimeters long at birth. During the beginning of its life, the Gila monster's length increases by about 15% each week. Alright, we're asked to write a function that models the length of the Gila monster at the beginning of the Gila monster's life. Alright, we're using x for the number of weeks and y for the length of the Gila monster. So y is going to be equal to the initial value, 16 centimeters, times the rate as a decimal, and this is growth, so we're going to add instead of subtract to the x power. And of course I could do a little bit of simplifying and rewrite it like that. Alright, and if I want to find the value of this at that point, all I need to do is take my 16 times 1.15 and put it to the third power, because each week this thing grows that much, which means by the end of the third week, the 16 centimeter long Gila monster is now 24 1/3 centimeters long. Alright. The last two problems deal with writing exponential functions from a table. Alright. First thing we're going to look at is, are we growing or decaying? So as we look at our y values, as our x value increases, you'll notice our y value is decreasing. All right, so that would be decaying. All right, and so what we need to do is figure out how this is happening. So from here to here, it looks to me like I'm dividing by 4. Again, dividing by 4, and once again, dividing by 4. Keep in mind we don't actually use division, so what we're going to say instead is that we're multiplying by 1/4. That is our actual factor. Our decay factor is 1/4. Now, the initial value is when x is 0. We actually don't have that, so we're going to have to work backwards to get that answer. So when we work backwards, we're doing the opposite of what's being done. So if I'm progressing up, which is down the table, but up in terms of the x value, all right, I'm dividing by 4. So if I want to go backwards, if I want to go from 1.5 to 5, I'm actually going to be multiplying by 4. Multiplying by 4, multiplying by 4. So if I have to go back to 0, I'm going to multiply this thing by 4. All right, and that's going to get me 320 as my initial value. Okay. All right, and then the last one here. You could see, if I ignore the negative sign for a second, you could see that these numbers are increasing. So what's happening here is I'm multiplying by 3, multiplying by 3, and multiplying by 3 to increase that value. So my function is going to be y equals something times 3 to the x power. Once again, I'm not given the 0 value, so I am going to have to work backwards. All right, and the way I work backwards is by dividing. All right, so I get -1. So then, if I look forward, -1 times 3 is -3, and so on. So we have -1, and then 3 to the x power. All right, good luck on your finals.